Any other ideas? So we had technology.
Luxury goods.
Yeah, so that's actually a little bit of an odd one. I would agree to this, absolutely, that people spend more money on kind of the Rolex and expensive stuff. The problem is that there are some things which are kind of so ridiculously expensive that there are filthy rich people who buy this stuff anyways. Right? So actually you have the point that some luxury goods companies are remarkably stable even in times of recessions because people continue buying the stuff, right? The rich people. Right? And the rich people are not so much affected by the recession. I personally would not be able to afford a Rolex, right? Anyways, so for me, in my situation, it's not relevant at all, right? But like someone like Jeff Bezos has maybe 5 Rolex on his arm, right? He doesn't care how the economy's doing, right? In his decision to buy the next one. So it's a little bit of an odd one. I totally agree that luxury goods should be pro-cyclical fundamentally. And for most people in the world, it's like 99%, probably 99.9% it is. But if it's a product that's bought by a very exclusive small group of people, they probably don't care. Yeah, so luxury goods.
There was kind of relation in luxury goods if we assess the group of people who were trading the cryptocurrencies and stuff, because this group of people immediately became rich and they started to buy Rolexes, Pateks, and etc. So they kind of created a big demand to it.
Yeah.
So now we can see the opposite thing, that they kind of get more poor, let's say. So
Yes, it's the same argument as with the investment bankers who kind of immediately buy their expensive car after they get their bonus, right? So people get rich fast, they usually spend it fast again. So last type of company that we could maybe mention would be the actually the energy companies most of the time, because at least oil prices tend to be rather pro-cyclical. Energy demand is high when the economies are doing well. An example would be in the early 2000s to 2002, the financial crisis, 2006 and 2007, there was a big increase in commodity prices across the globe, and the reason for that was that China's economy was growing like hell, and they were importing steel, coal, oil, and so on, driving up the global prices. So there was a clear positive relationship between the economy, especially in China, and imports and the prices. So the global commodity and energy companies benefited from that. So in that time period, it was definitely pro-cyclical.
Maybe also travel companies.
Yeah, that's a good
Can
point.
also be considered the same the same place as the luxury stuff. Like when we can travel at any time. But maybe like when we consider the companies, they make more profits when the market is.
Yeah, probably leisure companies, travel companies. That's actually probably a better pro-cyclical example than the luxury part. If you take out the luxury travel, right? But the average people's travel, like if you are in a recession, you have to pay 10% inflation, you have to pay twice as much for your heating costs. What is the first expense that you will cut, right? You say, okay, maybe I don't go to a vacation for 2 years or twice a year maybe, or just drive to the North Sea or in Germany or to the east to the Baltic Sea and stay and spend less on things that I can easily cut. And travel is, vacation is probably the one that you would cut first, right, as an average household. I had times in my life when my parents had to cut vacations for that very reason, so I experienced that. So that's a good point. So I actually think that if you go through every industry kind of in your head, you will be able to kind of assign it to any of these buckets. Of course, it's situational because it's the question, what's the crisis, right? We talked about war, we talked about the pandemic, and then there's kind of overall recessions, and all of that might be different. And what we see in the data is that, well, here we have actual numbers, and I told you these are the true numbers. But in real life, we would have to estimate them. And now these estimates can change over time, either because of our estimation procedures with different data, but also because the fundamentals can change over time, right? So the economy today is probably not the same as 20 years ago, right? So just keep that in mind, that risk measures, as we measure them in the data, are not something that's a constant and should be like that forever, but that they're kind of evolving and changing over time. Like one example would be if two companies, for example, are merging together and create a new company. The new company is totally different. when you estimate risk measures for that company, do not use any data before the merger, right? Because then you're looking at different things. You have to collect data on that new company. In terms of statistics, and we come to that in the data assignment, you always have to think about, from a statistical point of view, it is better to use as much data as possible. So to go to at least 100 years of data, right? Because then you can estimate something reliably from statistics. However, the more far in the past the data is, the less representative it might be for the thing that you actually want to analyze, right? So you have this balance between how much data to use and how representative the data actually is. And there is, well, unfortunately for us, but maybe it's also a good thing, it's up to you to make a choice there, right? So when you measure these things, you have to make a decision on how much data you want to use, the frequency of data. There is no right or wrong, right? That's the good thing. The bad thing is I can not tell you exactly, or give you a lot of guidance, right? So this runs down to trying out things and experience in the market, in the job, basically. Good. So this slide here summarizes our findings on the beta, and let me quickly kind of illustrate what the beta of the market should be. So the beta of the market would be the covariance of the market with itself divided by the variance of the market, right? So if you now plug in the formula for the covariance, what do you get? You get the sum over the probability times, now the return of the market minus the expected return of the market. And now the same thing again, right? The benchmark minus its expected value. If you now look at this, so this was just plugging in here. Here we had the single asset before, now I just plugged in the market itself for this. If you shorten this, what do you get? You get the return of the market minus expected value squared, right? And that is exactly the formula for the variance itself. Right? So this here is going to be equal to the variance of the market in the numerator and in the denominator. Right? So this always has to be 1 then by definition. So what we did here, I used the formula from before, but I plugged in for the share, I plugged in the market itself. So just keep that in mind as a useful result, that the covariance of a variable with itself is equal to its variance. So let's use the final minutes of today to think a little bit about this backward-looking perspective. So I've introduced the two risk measures, volatility and beta, and we will see the relevance for theories later on. So there will be a theory called portfolio theory that works with volatility, and then we develop out of that the capital asset pricing model, and that will rely on the beta. And the beta will be linked to the discount rate at the end. Right? So both risk measures are important. They measure different things. I hope that from this example you have a good intuition what they measure. And in the next 2 weeks, we see basically how they're used in the theories and where the different relevances for them. So, and let's take the time for the rest of the time today to look at kind of how do we actually estimate those things. So you will now see a totally different set of formulas for the same variables, right? We have the expected return, the volatility, and the beta, and now we are estimating these using historical data. So to distinguish the formulas, I will put this little hat on top of that. That's kind of standard notation in statistics. That the hat here, actually broke this down here in the next bullet. The hat on top of the variable name notes that this is an estimate for something. So basically it's the example of the coin flip, right? You flip the coin 100 times and then you have 100 observations. And then you, so the thing that is not in the formula anymore is the probability, right? We don't know the probabilities, so they're gone. What's new here is the first term, 1 over t. So t is the number of observations that we have, right? Number of days in our sample. So why do we do that? Why do we just divide by the number of observations? Why do we just do simple averaging? Well, the idea is that if something has a higher probability, it will show up more often in our data set. Right? So basically by doing this, I treat every observation as equally likely. Right? But if something has a higher probability, the same observation will show up multiple times.